Welcome to another deep dive. Today we're really getting into a topic that's changing the game for learning, especially,
Yeah.
now that everything's so digital. We're talking about virtual laboratories in education, how they actually work, using things like virtualization and cloud computing and what it all means. Sort of like treating IT resources like, well, like water from the tap, always there when you need it.
Exactly.
Go-
And we've got some really interesting research to draw on for this one. Papers from places like the Urban Vocational College of Sichuan, University of Antwerp, Nankai University Northeastern, a good mix. So our plan today is basically this. Look at why the old traditional labs were becoming such a headache, explain the tech behind these new virtual setups, and then really dig into the benefits. And importantly, also some of the maybe surprising downsides and things to think about going forward.
Okay, sounds good. Let's unpack this. So for years, decades really, traditional computer labs were just standard, the norm. But they definitely came with their own set of problems, didn't they?
Oh, absolutely. The old way of building data centers, it just struggled a lot. Think about the money involved constantly buying new hardware, upgrading it,
Yeah.
then wrestling with compatibility issues, machines not talking to each other right, and just the sheer effort of managing all that gear often spread out. Some of the sources we looked at pointed out that, adding even one new course might mean setting up a whole new server, which obviously leads to huge cost pressures, wasted resources, not to mention the power consumption. One paper even mentioned universities often struggling with funding, making it hard to provide top-notch IT.
Right. So it wasn't just the upfront cost, but also flexibility, efficiency,
Yeah.
and literally just finding the physical space for it all.
Precisely. Beyond the money and the management burden, traditional labs have these built-in limits, like fixed opening hours, specific locations you had to physically go to, and sometimes real safety concerns, especially with certain kinds of experiments. All of this really limited access, particularly for, say, distance learners. As one source put it, students and staff couldn't necessarily use a physical lab whenever inspiration struck, which directly hits learning flexibility.
Yeah, that makes total sense. So if the old way had these drawbacks, what exactly is a virtual lab? And what's the magic tech making it possible?
Well, at its heart, a virtual lab is basically a collection of computing tools, processing power, storage, networking that an institution provides online for learning. It gives students the IT setup they need to tackle real-world problems, either by themselves or in groups, all through the internet. Now, you hear virtual labs and remote labs thrown around. It's interesting, there's a slight difference. A virtual lab usually simulates a real lab. Think of it like a very sophisticated simulation, whereas a remote lab actually gives you online control over real physical equipment somewhere else. Like National Instruments Lab BUW can let you remotely control a real robot arm or a control system, sometimes even with a live video feed. Pretty cool stuff.
Okay, that distinction is helpful. And you mentioned cloud computing and virtualization powering this.
Yeah.
Can you maybe break that down a bit for us? How did that work?
Sure. So cloud computing is what lets us access these IT resources like services back to that water and electricity idea. There are sort of three main flavors. First, you've got infrastructure as a service, or IaaS. Here, the cloud company provides the basic building blocks, virtual computers, storage, networks. The university manages the operating systems and the applications on top. It's like renting the raw hardware.
Okay, hardware as a service. Got it.
Then there's platform as a service, PaaS. In this case, the cloud provider manages the underlying infrastructure and the operating systems, maybe databases too. The university just focuses on building and running its own applications. This can really speed things up.
Right, so you don't worry about the plumbing. Just build your application.
Exactly. And finally, software as a service, SaaS. This is probably the most common one people use day to day. Think webmail or online office suites. The provider manages everything, hardware, software, updates. You just log in and use it through a browser.
Okay, iOS, PaaS, SaaS. Makes sense. And virtualization is the key ingredient underneath all that.
It really is. Virtualization is the technology that lets one physical computer pretend to be many separate computers. It sort of creates this abstraction layer hiding the physical hardware. It breaks down those old barriers between physical machines. This means you can use the hardware much, much more efficiently. For example, there's a technique called paravirtualization. It's a bit technical, but essentially the virtual machine knows it's virtual and it can talk more directly to the underlying system, the hypervisor. Makes things run faster.
So we've covered the problems, we've covered the tech. Now, the big question. What are the actual payoffs? For students, for the institutions, what are the game-changing benefits here?
Oh, the benefits are pretty significant. They really hit on a lot of those pain points of traditional labs. First off, cost effectiveness. This is often huge. One study we looked at did a direct comparison Azure Lab Services versus building it yourself on-premise over 5 years, assuming like 50 virtual machines per class. They found using Azure was up to 26% cheaper. We're talking around $235,000 versus, well, quite a bit more for the on-premise setup. And a big part of that is the pay-as-you-go model. You only pay when the virtual machines are actually running.
Wow, 26% that's a serious saving.
It really is. Then there's speed and flexibility. Setting up a lab. Incredibly fast now. That same study timed it using scripts. They could get a whole virtual lab environment up in about 132 minutes. Minimal clicking around. Compare that to potentially days or weeks for physical hardware. This means you can get computing power to students almost instantly. They can rent what they need when they need it.
Okay, so cheaper and faster. What else?
Accessibility and scalability. This is key. Virtual labs mean 204/7 access from anywhere with internet. Students can use their own laptops, their own devices. It really opens things up. And for the institutions, it lets them build these really robust, scalable platforms that can grow as needed, meeting those innovation demands. Students can even redo complex experiments at home that was practically impossible before.
That ability to practice and repeat must make a real difference to learning.
Absolutely. And that leads right into enhanced learning outcomes. This is where it gets really exciting. We saw evidence from several places. At Nankai University, they used VR and AR in virtual labs for medical courses, things like detecting microbes. The results showed a definite positive impact. The students using the virtual labs scored higher on exams.
Interesting. Using VR and AR, too.
Yeah. And at Northeastern University, they set up a virtual lab for a big online course, a MOOC, on computer control systems. They found it significantly boosted student interest and deepened their understanding of the material. Again, the groups using the virtual lab consistently got higher final exam scores, like a 3.78 average versus 3.44 for the control group 1 year.
So measurable improvements in scores.
Well, measurable, yeah. And another study, this one from the Polytechnic School of Chimborazo, used what they called a social cloud for IT skills. They found statistically significant improvements across 4 areas. Learning to know, basically academic results were better. Learning to live together, and learning to do, which pointed to better practical skills, according to the students themselves.
Wow, across the board improvement there.
It seems so. And finally, don't forget safety and environment. Virtual labs mean students can work with simulated hazardous materials or huge expensive equipment without any physical risk. Or environmental constraints. They can run simulations that would just be too dangerous or impractical in a real lab.
Okay, those benefits are really compelling. Cheaper, faster, more accessible, better learning outcomes, safer. It sounds almost perfect. But, new tech always brings new challenges, right?
Yeah.
What are the potential downsides or hurdles people should be thinking about?
You're absolutely right to ask. It's not all smooth sailing. There are definitely challenges to consider. First, the technical challenges. Things like network lag, latency, and just the speed of your internet connection. These can really affect the experience. A slow or choppy connection can be frustrating, lead to lost work. Researchers actually measure things like RTT, round trip time, how long signals take to go back and forth, and max session input delay, that little lag between clicking and seeing the result. One study found an average lag of about 9.65 milliseconds. Which sounds tiny, but it can be noticeable, especially in fast-paced tasks.
Right, that little bit of delay can be really annoying.
It can. And you also need to make sure the virtual machines themselves are powerful enough for what students need to do. Running something complex like Visual Studio requires decent specs.
Okay, so performance and connection speed are key. What else?
While financial hurdles can still pop up, just in different ways, while the cloud infrastructure might be cheaper overall, the cost of software licenses, especially for proprietary stuff like Adobe Creative Suite or Microsoft Office, can still be really high. If the software companies aren't offering good licensing deals for these virtual users, that cost can really add up. And research shows these are heavily used applications.
So the software licensing is a potential catch.
Yeah.
That's a good point.
Definitely something to budget for.
Yeah.
Then you have organizational and pedagogical challenges. These are more about the human side. There's a potential risk of social isolation. Less face-to-face time can impact communication skills, maybe even contribute to stress.
The social aspect.
Yeah. And some students might struggle with self-motivation. Without the structure and peer pressure of a physical lab, it requires more self-discipline. Interestingly, some studies found students actually prefer physical labs for group work and just hanging out. So maybe a blended approach is best.
Finding that balance.
Exactly. And one more, maybe less obvious thing, ergonomics. Just because it's virtual doesn't mean physical comfort doesn't matter. Bad posture, poor chair setup, monitor height, lighting. These things still cause discomfort, even injury, when you're working online for hours. Studies actually found high rates of things like unmatched seat syndrome or muscle pain among students working remotely.
Huh. You wouldn't necessarily think of ergonomics for virtual labs, but it makes sense.
It does. So, based on all this research, there's some practical advice for institutions setting these up. Number one, student training. Don't just throw them. Provide really clear step-by-step guides, maybe an initial training session on the cloud tools.
Good onboarding, basically.
Right. And number two, strict cost control. Since you pay for usage, you need clear rules. Things like always shut down your virtual machines when you're done. Choose the smallest machine type that works. Clean up old or stopped instances. Some places even factor the cost students generate into their grades to really encourage responsibility.
Okay, training and cost management were crucial.
Very much so.
This has been a fascinating deep dive. It really shows how virtual labs are fundamentally changing education, offering this amazing accessibility, flexibility, cost savings. But like you said, it's not without its challenges. It solves old problems, but introduces new things to think about, from network lag to social dynamics.
Indeed. It's clear that integrating cloud and virtualization is making really sophisticated learning experiences available much more widely. It's fostering learning in ways we couldn't easily do before. But the key really is leveraging these tools thoughtfully while actively managing those unique challenges.
So, thinking ahead, what does this mean for you listening? We're seeing these virtual environments become more than just replacements. They're expanding what's possible. How might this constant availability of dynamic, personalized learning spaces change how we even measure skills or creativity or teamwork? And what completely new kinds of innovation might pop up when the physical limits of a lab just aren't there anymore? Could we see students from different continents collaborating on complex virtual experiments in real time? Lots to think about. Thank you for joining us on this deep dive. We hope this exploration has given you plenty to consider.